that's number one, all right? Now we're gonna take a look at number two, okay? So number two, it's gonna give you, again, this is sinusoidal, okay? We're gonna see the tide goes in and comes out. It says at 5 a.m., the water depth, okay, was at a maximum, so that's super important, of 10 feet. So at 5 a.m., okay, water depth maximum of 10 feet. However, by 11:30, okay, so there's our time again, we hit a minimum of 2 feet. Okay, so can you see our mins and our maxes? So let's get started here, okay? And these can go into the negatives, okay? On these two examples, they haven't, okay, but they will, all right? In our later examples. So here we have a maximum at 10, okay? And that happens at 5 a.m. So remember, 5 a.m. So this would be at 0, so 5 hours later. So this is my hours. And then this should be the height of the water, okay, because we're talking about that. So this is height of water. Okay, so we're going to go to that maximum after 5 hours. So there's my boundary line, okay? And then at 11:30, so 11:30, this will happen, right? And we'll hit our minimum, I believe, of 2. So there's that. Now, how much time has passed here, right? This is 6, so this is 11.5, right? And therefore, since this varies sinusoidally, we know if it hit a maximum here and then a minimum, it's going to hit that maximum in the same amount of time. So we're going to add another 6.5. So this is, we're going to add 6.5, right? This guy was 6.5. That's how much time has gone by. So this is how many hours? So 17, 18. So now 18 hours after 0, right? Later, we're going to hit our maximum again, okay? Now if I connect these, you can see that, weirdly enough, it's just a sketch, but that's my cosine curve, isn't it? Because this is my maximum, so I'm not going to go up and above this. This is my minimum, so I'm not going to go below that, all right? Because this is a sinusoidal function. So I have my mins, my maxes, and then we're going to come back to the max because we started with a max, all right? Now, we have our boundary lines, right? This is a difference. I'm going to do exactly what I did up above. So the difference, 10 minus 2, that's 8. So I need the middle of that. So I'm going to divide by 2, which is 4, right? So I need to go have my midline have 4 units above and below, right? For a total of 8. So therefore, this will be at 6, right? And then there'll be a difference of 4 there. So that means my amplitude is 4. My midline happens at y equals 6. So that's my A. This is my D. Okay, so I have A and D. And then I know I'm starting high, right, at my max. So I'm going to have a cosine curve. So this is going to be y equals 4. It's a positive 4 because I start at my max. If I start at my min, that would be a reflection, and I'd make that negative. But this is 4 cosine, right? I'm not sure. Do I have a shift? Well, okay, I started at a high, which means it was cosine, but I didn't start at the 0 point. I started at the 5 point. So that means it's going to be x minus 5 for my phase shift. And then my D value, we said, right, was, this is at y equals 6, so I'm going to add 6. And now the last thing I have to do is find my period, right? So remember, up above, when we found our period, we went from the beginning, our initial maximum, to our ending maximum, okay? Now, I'm going max to max because this is a cosine curve. If this had been a sine curve, I'd go from midline back to the midline, okay? And that would give me my full sine curve. But here, I can see this is 6.5, that's 6.5, so that's a total of, I believe, 13. So that's my period. So my period is 13 hours, right? So to find B, right, just like we've been doing, okay, we're going to do 2 pi over B equals 13. So 2 pi equals 13b. Divide by 13. B is 2 pi over 13. Not going to be pretty, so I'm going to put that up there. And I'm always going to add my brackets here so that I remember to put them in my calculator when I have to do my calculator, okay? So that's my equation. So that's my equation, all right? So y equals 4 cosine, big bracket, 2 pi over 13, x minus 5 for my shift, close those brackets, plus 6, okay? So T is F, hours after midnight. I used X instead, so I'm just going to change that. All right, and depth, right, I used Y instead, okay? It doesn't really matter what variables you use, okay? So they want us to find the depth at midnight, okay, when T is 0, okay? So that's where we're going to plug into our equation, right? So Y equals 4 cosine 2 pi over 13, 0 minus 5, plus 6. So again, we're in radian measure, so I'm going to put that in my calculator. So what is that? 4 cosine. Okay, then I have another set of parentheses for my B value. Oops, forgot my divided. Then this is 0 minus 5, which is just negative 5. And then I close the parentheses for that whole expression. Okay, again, you could have multiplied those out and then put that in your calculator. I'm just plugging it in, letting the calculator do all the work. Plus 6, and there you go. So that will be about, right, that's, I mean, we'll round to the nearest hundredth, so 3.01. Now, if I continue this curve, would that kind of make sense? Yeah, it should be probably somewhere around there, okay? Because this will reach a minimum again at 6.5, won't it? So a little bit past 0, right? But we're not really going to graph negatives, but it would come down and hit a minimum about there. So that makes sense, okay? It should make sense with your graph, okay? And then at 3 p.m., what is the water depth? Okay, so 3 p.m., right, is how many hours after our 0 time, right? So that's, we went 0 to 12, right? And then another 3 hours. So 12 hours plus the additional 3 hours means that 15 hours have passed, right? So we're going to plug in x equals 15 into our calculator, right? So that means we're going to do 4 cosine 2 pi over 13, right? Then we'll have 15 minus 5 plus 6. Okay, this guy should have the brackets around it. And then we'll put that in our calculator, okay? So 4 cos, okay? Then 2, our B value, putting in our parentheses, 13, and then what's that, 15? So that's 10, 15 minus 5, close those parentheses around the whole thing, plus 6, and there you go. So that would happen at, what, 6.48 beat? And if you look, does that make sense? Well, we hit a minimum at 11:30, didn't we? 11.5. So at 3 o'clock, right, we should be closer to that, right? Above 2, but not a lot above 2, right? So, because at the end, to get to the maximum would be 18 hours, right? And we're only at 15. So somewhere in here. So that seems reasonable, okay? Then our last question is, if I will only dive in the water when it is above 8 feet, what is the range of time in 24 hours that I can do that, all right? So what you have to think about there is you only want it to be above 8 feet. So if we look here, that would be, okay, when y equals 8, wouldn't it? So that would be a line somewhere here. All right. So what we want to do there, okay, is how much time, okay, would pass. So what you want to think about is when will this and this line, this would intersect, okay, and we're going to do more of this, but this graph will intersect this twice here, won't it? Okay, so what I'm going to do is use my calculator to find that. So what we're going to do is we're going to go to y equals, okay, we're going to hit clear, okay, get rid of anything that's in there. You're in radian measure, okay, so it's going to graph in radian measure. I'm going to put our equation in there. So y equals, okay, so I'm going to work here and then we'll go to our other sheet for our answer. So y equals, what is it, 4 cos, right? Then you need another set of parentheses for the 2 pi over 13. Okay, and then I'm going to have x minus 5. Close those parentheses for the x minus 5, and then for the whole expression that we're taking the cosine of, and then add 6, okay? Now, you're going to have to change your window, but you've already determined what your window should look like with your sketch. So usually we're not going to be dealing with any negatives in these word problems, so I just made x start at a -2, okay? So there was a little space to the left. And then I should be going out all the way to about 18 hours, right, according to our sketch. So let's make that, I don't know, 20. Then my x scale is 1, okay? My y min is 0, okay? You could make that a -2 as well, right? Because in this problem, we really don't have any negatives, so I'm making my negative, my min's very small. And then I should hit a maximum of 10, so maybe let's make that 11, okay? So now I'm going to hit graph. And then if you take a look, this matches my graph here. Do you see here's my max, there's my maximum, right? Then here's my other maximum by the time I get to, remember we set this at 20, there's my other maximum. So here's my cosine curve, okay? So if I look now, I want when it intersects y equals 8. So I'm going to go back, put 8 in, and I'm going to find the 2 points where it intersects here. So second calc, our favorite button. Oh, I hit alpha. Second calc, intersect. And this one you don't have to worry about left bound, right bound. It's just get close to that intersection point. So moving my spider over to this point where y equals 8 and my cosine curve intersect, hit enter 3 times. And that happens at 2.83333. So 2.833, comma 8. Okay, then I'm going to go over to my next intersection point. So second, trace, intersect. Move my cursor all the way over. And that happens at 7.166, comma 8. So between 2.8 hours, right, and 7.1 hours, okay, I'm above a water depth of 8. Now, is that going to happen again? Yes, it is. It's going to happen here and then from there, right? Now, we can change our window to go all the way out, right? Our X max was 20. If we make it 24, so that would be 24 hours, right? If I hit graph, you will see it's only above that twice. So if I find the difference between my hours, I'm going to multiply that by 2, and that is going to give me my amount of time. So my work here is I'm going to take 7, right? If we come back up here, 7.166 minus 2.833. Okay, so 7.166 minus 2.833. Okay, so on my calculator, let's do that. And that's going to give me 4.333 hours, right? Now, if you remember, right, when we look at our graph, that happens not once, but twice in a 24-hour period. So I'm going to multiply that by 2, right? 2. And that will be for about 8.666 hours, which is about 8 hours and 40 minutes, right? Because really, 0.66 times 60, right? Isn't that about 40 minutes? Okay, so 8 hours and 40 minutes. All right, so you need the calculator, okay, to find that span of time, and you're going to have to use the intersection key, okay? I think there's one like that on the homework. We'll be doing more, okay? So give it a try. Check my answer key, and I think that's all I got. Hopefully this was darker. Some of the feedback I got is you couldn't read what I was writing, so I tried to use a different pencil here, okay? And I will talk to you guys soon.